Okay, welcome everybody. This is the last lecture as an online lecture that we'll have for this module. Don't forget that next week we're supposed to come into the lab and start out actually working, the practical work on the material. Kind request, please come to the allocated lab session that as it shows up on your timetable. All of the labs run on Tuesday and there are 4 timetable slots. If you want to move, and if you're thinking of moving, please don't. Okay, come to the slot that has been allocated to you. Because if you don't, then attendance, the electronic attendance system will not work. Okay, so then it will seem like you're not attending the classes and you'll have a problem. Right. Also, because it's only 2 hours, especially for the first week, I don't care about this so much for the following weeks, but especially for the first week, I would like you to come into class. I'd like to be there about 10 minutes earlier because you will need to sit down on the computer. So we'll need to arrange where everybody will sit, and I'll need to take attendance and populate my list because I have a diagram essentially of the class and where everybody is sitting. Okay, so there's a little bit of admin work to do next week. So please come a little bit early so that we don't take up too much of the 2 hours of the lab time sorting out these details. So today I'm going to explain the last of the labs that we have available, which is DNS. So far you will have built, actually the diagram will help. So far you will have built your Prometheus virtual machine, which we use as a server, as a host. You will have built your 3 virtual machines in order to create your little virtual network. And you will have basically done routing between them, so you will be able to have full internet access between those virtual machines. So the last thing that you will do is you'll set up a DNS into the network. So essentially we will turn this computer, your Prometheus host virtual machine, into a DNS server. Now, a little bit of background about DNS. DNS stands for Domain Name Service or Domain Name System. And it's what allows us humans to go onto a web browser or look for a computer by its name. So we don't need to remember an IP address or somewhere to go. We can basically convert it into a name such as google.com or port.ac UK, and then it allows us to just input that address onto the browser bar or in a terminal if we're trying to ping it and so on. So we don't actually have to remember the numbers. Okay, this whole idea started because in the first early days of the internet, people used to have files that we call host files, and they still exist today as well. And every week, every Friday, they would basically upload via FTP the host file that would contain all of the IP addresses to name allocations for every computer on the internet. Of course, that was fine when the computers on the internet were maybe a few hundreds or a few thousands even. But of course, now this is not feasible. It's impossible, and it has been impossible for many years now, many decades. God, yes. So now what we do is we use DNS. So it's a system that basically allows us to have names for our computers, one, and the second, to allow other people to look for our computers by name. So how do we do it? First of all, we need to understand what the names actually mean. So the convention that we will use in our labs is you will have a prefix and a suffix. So for example, your Prometheus host, Prometheus is the first name, let's say, and netlab port.ac UK is the surname, is the suffix. All right. So prefix and suffix in a name. The prefix is the name of the particular computer that you want to access, and the suffix is essentially something like the surname, something like the network neighborhood, the domain where your computer actually belongs to. All computers in the lab at the moment belong to netlab port.ac UK. So netlab is our A2.NET class, and every dot in this name actually means something. So Prometheus netlab port.ac UK means that we're talking about the Prometheus computer that belongs to netlab, that belongs to what used to be electronic engineering on that floor in Anglesey building, that belongs to University of Portsmouth, that belongs to Janet, the Joint Academic Network, so where all the universities in the UK belong, and the UK, which means it belongs to the UK. Now, for all of these dots, there is a server somewhere. So Prometheus is the first name, is the prefix, and Prometheus NetLab hypothesis UK. NetLab is the domain that we have, and there is a DNS server for the NetLab domain, and this is called an authoritative server. So it's the server that knows everything, all of the computers that belong to the NetLab domain. The NetLab domain is basically in the lab. So everything inside day2.net belongs to NetLab. So we have a computer, its name is Columbus in the lab. So Columbus is the DNS server for anything that starts with NetLab. Beyond that, we have the EE, that's there for historical reasons pretty much. EE stands for electronic engineering, okay? So this is quite old, yeah. And this is because this Anglesey building used to be electronic engineering, and because our computers were so advanced, we had our own domain in there. Because of the way that our university structure advanced and progressed over the years, the electronic engineering department was the first one to have computers and IP addresses and all that. In fact, one of our system administrators that has now retired, Philip True, is responsible for the university owning an entire Class B network of 148.197.0.0. Yes, it's a huge privilege and possibly a waste, somebody could consider it, but hey ho. So we have 65,000 IP addresses available to use simply because Phil, when IP addressing came out as an idea, he thought, oh yeah, this is going to be useful. Let's get a Class B for ourselves. And that's how we ended up with 148.197. So yes, it all means something. So EE is electronic engineering. There is a domain name server for this part of the name as well. So this controls computers that are in basically A2.NET, A22, and A23. So all of the computers that are left now that are still under that control, it's the machines that are running Linux in Anglesey building, essentially. We then have the port domain, which is University of Portsmouth, which is the university's main domain server. So in the university, there is an authoritative DNS server for the port domain. I think it's at 148.197.8.12. Then after that, we have AC, which belongs to Janet. So Janet is the ISP for all the universities and some of the bigger colleges in the UK, and they have authoritative servers. They are the authoritative server for anything AC. And then UK will go up to the tier 1 ISP that provides all of the names and addresses and all that to the UK domain. So everything that's basically in the United Kingdom. So what we will do in the lab is we will add one more level into this thing. So before NetLab, you will each have your own domain that you will be responsible for, and you will build an authoritative server on Prometheus for your own domain. Your own domain will be the name of your PC. So if you're sitting on Sato, your full final name after the DNS should be prometheus.sato.netlab.e port AC UK. If you're sitting on anything else, if you're sitting on Hamilton, it should be prometheus.hamilton, netlab.e port AC UK, and so on. So the idea is that you will build your authoritative server for your computer name's domain onto Prometheus itself. And then you will tell your computer to point to that domain so that to that server so that it does its address resolution. And then once that works, you will then point all of your computers inside your virtual network to your DNS server, and that will do its resolution as well. All right. Before we do all of this, before we install the service, we will need to rename our computers. Very easy to do. All you need to do is go to the etc. host name file, okay, and change the name in there. So the name in there for Prometheus should be prometheus.netlab.e.port.ac.uk, you will simply rename it to prometheus.sato.netlab.uk or whatever your domain actually is. Okay, you do that and you restart. You will also need to repeat the same process. You need to rename all of your virtual machines. So you will have vprometheus0.sato.netlab.uk. And then once you do that, you will also basically need to go into your network card settings and you need to change your search path to sato.netlab.uk or whatever your computer name is. And you will have a look in etc.resolve.com because that's the file that basically tells your system where to go and look for a DNS server and put the IP address of your DNS server and your search path in there. So at the moment, your DNS server IP address will be something like 148.167.28.1, which is the IP address of Columbus, who is the authoritative server for the NetLab domain. So now we'll take things one level down. You will change all of your DNS server IP address to 148.167.28. whatever you have for your Prometheus virtual machine. Once you have all of the names set up and you've configured your computers to point to your own DNS server, we can basically install the software that will do this. The software for DNS in Linux is called Bind. So all you need is yum-y install bind and bind utils. This will basically download and install the software on its own. You don't really need to do anything about it. Just make sure you get a screenshot of it to say that, yes, I installed it, hooray. And then we need to start configuring the service. Certain files go to certain locations in the DNS service, so we'll look at that. The service depends on a file called namedemon.conf. It lives in etc., just like most of the services that are run in Linux. So you need to configure that file, you need to edit it, and you will need to tell it two things. There are two changes that you need to make in name.conf. The first one is to configure the service to listen to a particular IP address. So for example, your ENS33 address on your host. Okay. So what you need to do is you need to change this one here. So it should listen on port 33 because port 33 is where the DNS service actually runs. It should always listen on the loopback interface, your home 127.0.0.1. All right. And it should also listen on the IP address for your ENS33. This is because everybody else will use that IP address as their DNS server. Okay, so this IP address is just an example. For you, it will be 148.197.28 something. Okay. Once you have the IP address configured correctly, you then need to tell your DNS server which networks are allowed to access that DNS server. So you allow queries, so you go to the allow query statement, and you need to have all of the network addresses for all of the networks that exist on your computer. Remember, in the virtual network lab sheet, we subnet our subnets, so we have subnets 30, 31, and 32. Okay, and each of your computers will have its own network address. It will be 0, 4, 8, 16, 32, whatever it is. That network address needs to go in this statement. So obviously, at first, you'll have a 148.197.28.0, which will be the same for everybody in the lab because you all belong to subnet 28. And then you'll have your subnets 30, 31, and 32 with their IP addresses, with their network addresses. So this will allow your server to be queried, to be asked about names from everybody on subnet 28, so everybody in the lab. All right, so every other computer in the lab will be able to ask your computer for a name. So if, for example, you're sitting on computer Sato and you want to contact computer Hamilton, if you're sitting on V Sato 2 and you want to ping V Hamilton 1, then that request will start from V Sato 2, will go to its authoritative server, which will be the Prometheus server on Sato, And that server will then not find an answer, so it will ask the servers around it. So it will eventually come to Sato. Sato will say, oh yes, I know this Sato domain, it's mine. I am the authoritative server for it. So you're looking for vSato2, here's the IP address, ping it. So this, the fact that you're allowed to have any queries on subnet 28 as a whole, will basically allow other computers in the network to ping, to query your own machines, your own virtual machines. Because remember, nobody else in the lab knows the IP address to name mapping of your virtual machine. Everybody will know the IP address to name mapping of your Prometheus virtual machine. Okay, because that will come from our NetLab server, but nobody will know your virtual machines inside it. All right, so they need to eventually access that authoritative server, which will be whatever you have running on Prometheus on your computer. Now, once you've configured your name d.conf, you told that it's running on a specific IP address and it can listen to specific networks for requests, you create what we call the zones. So essentially the domain for which your computer will be working on. So your zone will be Sato NetLab port SCUK. You're the master of that zone. It's authoritative server, and there's some database file for it, and it's allowed to update. You don't need to do much on this. The only thing you need to set is your PC name here. Okay, so this zone should be like this, and it should exist inside basically named.conf. Together with the forward zones, we also have reverse zones. So DNS as a service should not only allow name to IP address mapping, it should also allow IP address to name mapping. So you can query and you should be able to query an IP address, and then the system should tell you, oh yes, that IP address belongs to that name. This is in case, for example, somebody contacts your computer, someone tries to ping you, or somebody tries to hack your computer, and then you can find possibly where that computer belongs, or which domain it belongs to, for example. Again, you need to set up the network addresses. They need to be in reverse order. So if my network is 192.168.40.0, the reverse zone will be 192.168.40 without the last bit. So we essentially only need the network part of it. Okay, so you put that in reverse and you create, and you will have a DB file, which is called a zone file essentially. You will also need, in the same manner, in the same way, you need to create reverse zones for 30, 31, and 32 as well. Now, once you have all of this information in named.conf, you can go and actually create the zone files that these references belong to, because they are mentioning files that exist on the system. Okay, so you need to create those files so that they exist a bit more. So cat basically the DNS's job is to say ping google.com, and then your DNS server and then Google's DNS server eventually will tell the computer that look, if you're looking for google.com, the IP address for it is whatever. With reverse DNS, you can say dig, which is the command that we use, an IP address. Okay, so find an IP address, and it will tell you that this IP address belongs to a specific computer name, and most importantly, to a specific domain. Okay, so this means that if somebody tries to contact your computer and you can see their IP address, you can possibly see at least which organization that IP address belongs to. All right. And the mentions in the zones for everything are written in reverse. So if my network address is 192.168.40.0, then I will put 40.168.192, and I will leave the 0 part out. Yes. So this is what we call the reverse lookup name, basically. All right. And the file that we'll create, annoyingly, will be the correct way around. It will be 192.168.40 dB. Okay, so this is why we're using this. Honestly, I'm not that fast about the reverse lookup. Even if you don't get it going, it won't cost you a significant amount of marks. I mostly care about the forward lookup. Okay, the reverse lookup is just a cherry on the top, just to make it look pretty and everything. Okay. So we need to create the zone files, as we said. So by default, the zone lookup files will exist in folder var named. This folder will have been created once you've successfully installed bind with a yum install bind. If it's not there, it means that something has gone wrong with installation, or you simply forgot to do the command. Okay, so the zone files that you need will look something like this. So your PC name netlab port AC UK, so sato netlab port AC UK. And I have examples of all of these files actually. If we go back onto here, there's a folder called DNS utils, and that's on the DNS, so that's week 28th of November to 4th of December. So in that week, in that lab, you will be able to basically go and have access to all of the files. So there's the DB file, there's the zone files, and all that. Okay, so don't worry about creating the files from scratch. You will actually be able to download examples of the files and work on them, and actually just change names and IP addresses that you might need to change in there. All right. So once you edit your sato netlab port UK, so your forward zone file, you will need to have your essentially IP address to host name allocation. So you need to have your IP address of your server here in those three settings. And this is essentially the most important part of what this host name file will actually do. So this is where the IP address to computer name mapping will be provided for the virtual machines in your network. So you'll have Prometheus that has 3 IP addresses. For you, it will be 148.197.28 something, 30 something, and 31 something. You will have vPrometheus 0 that will be on 30 something else. You will have vPrometheus 1 that will have 2 IP addresses on networks 31 and 32. And you need to add one more line for vPrometheus 2 as well. That will also be on network 32. So once you have this little table here with all of your IP addresses and names, then you are basically able to give your DNS server the ability to tell computer names to IP addresses, to map computer names to IP addresses for all of the computers inside your network. So these are the computers that your DNS server is responsible for. Little tricky here, Prometheus, all of your computers will be called Prometheus. Yes, so this will be the same name for everybody. But then again, you all have a vPrometheus 0 and you all have vPrometheus 1 and 2. The difference is that your Prometheus is going to be called prometheus.sato.netlab port AC UK and vPrometheus 0.sato.netlab port AC UK, because this is the rest of your name. So don't be alarmed by the fact that all of the names will be the same here. Only the first names, only the prefixes are the same. The suffixes will be different for each computer that you're working. So once we go through this, we can then create a zone file for the reverse zone as well under the var name directory. There will be an example that we can use. It will look something like this. You don't need to do much into it. You need to set the name correctly here, and you need to set the last part of the IP address of your DNS server, because remember, this file only has 3 bits in the network, so 192.168.40. Okay, so it stands for internet and address. I think I explained it somewhere. So A is record and in is internet. It means that's an address online, basically available online. Okay, you don't need to change them at all. Okay, so you just need to change the names and IP addresses, and that's it. So then, if we go back to the file, because the file itself is 192.168.40, then you need to have here the last part of your IP address of your DNS server. So this will become 192.168.40 137. So in your case, it will be 148.197.28, and then the IP address of your Prometheus ENS33 network card here. Okay. So once you change the name and the last part of the address in the reverse lookup database file, you can basically create the files for zones 30, 31, and 32, and their contents will be identical. So they will be the same because they all refer to the same DNS server. All that will change is that you will be using different file names. So each zone will have a different file name. So it will be 148.197.30, and then that IP address will always stay the same in there. Once the zone files are created, you can restart the service because now you have your named.conf file that's referring to the zone files. You have created the zone files themselves as well. So you can basically start the service, run it, and start testing it. Before you start testing it, of course, you will also need to let the service go through the firewall. So you can add port 53, which is where the DNS server actually works. You can add it through the service, through the firewall, sorry, and then reload the firewall. So restart the firewall service, essentially. Cut in the practical, yes, of course. I will be there to help in the practicals, and you can do any research you like. Okay, no, you will definitely not be winging it, don't worry. Yes, and you'll be allowed to use anything at your disposal. You'll have internet access. Well, you'll have internet access on Prometheus at this point. You won't have internet access in the virtual machines. Okay, because this is the purpose of this whole thing. Right, but of course, yes, you can do your own research as well before you come in. And if you have any questions, then I'll answer everything. So you don't have to worry about it. Okay. So once you let the service through the firewall, it's time to test the thing. Okay, the command that we use for this is dig. So if you dig www.sato.net/lab/UK, so this will basically test your domain name, your suffix name on its own, then that command should come back with, yes, I know this, and it's coming from this particular computer, and it's coming from this particular IP address. So the authoritative server for that domain is 192.168.4137 at port 53 or whatever it is. Yeah. If you get a reply like this, it means that your DNS service is working. Your Sato NetLab Portplace UK domain is being recognized, and the server for that one is basically working correctly. So now you can change the DNS server on Prometheus's computer as well, because then now your DNS server is actually working, and you can try the dig command there. Finally, after trying the dig command on Prometheus and maybe on all of the virtual machines as well, you can try the second level of testing, which is to try to ping your vPrometheus 2 or vPrometheus 1 or 0. Okay, so there's two steps to this process. The one step is that all of your virtual machines and all of your computers in your network are able to ping addresses on the outside world. So you can try pinging Google, for example, .com from all of your virtual machines and see if that works. So if that works, it means that your network has correct IP address resolution for the rest of the universe. Okay, you can contact IP addresses on the outside. The second level to it is the other way around, that other people can actually contact your computers. So your authoritative DNS server is correctly giving the information out to every other client that is asking for an IP address from your own little network. Okay. Essentially, by the end of this lab sheet, you could partner up with students next to you, around you, friends, and so on, and you could all try to ping each other's computers across the different computers as well. Okay, but this is really in the end of it. Okay. So once you get to this point that you can ping your virtual machines by name and simply by name, you don't even have to put Sato NetLab Report UK behind it. Okay, then it means that your DNS is working correctly and completely, and you have pretty much finished the lab sheet. There is a bonus round to this as well, and it says you have all now set up an authoritative server for the same domain on your computers, resolving names like vPrometheus0 with different IP addresses. So why does everything still work? Okay, why do you all have computers that have the same first name, the same prefix? Okay, but everything just keeps working without any problems. All right. So this is for something to think about and maybe test as well if you want. So as a service in general, it's not very difficult to configure. You only have the named.conf file to configure the zones for it, and then configure the file zones and the host name. Once you do that, it's essentially we're talking about 5 or 6 files, and most of them are the same. As long as everything is in the right place, and as long as the permissions are correct, and you don't run into any weird problems like that, then the service should just run. It's very important that you understand the idea of how the naming conventions actually work. So your computer will be the server. You'll be responsible for a particular domain, which will be the domain name of whatever your computer is. So it will be prometheus.sato.netlab.uk. Okay. And all of the computers inside that domain need to be named in the same way, and they need to be pointing to yourself as the DNS server. There is a little trick that we do for backup as well. You can use multiple DNS servers. So even during the Linux setup lab sheet, the first lab sheet where you set up the operating system, the DNS servers that you set up on your Prometheus were 148.167.28.1, which is Columbus's IP address, which is the NetLab authoritative server. And then after that, we would leave a space and use 148.167.8.12, which is the authoritative server for the university itself. So if one DNS server doesn't work, the system will automatically try a second DNS server if you put it there, if you configured it to it. So what you can do at the end of this lab sheet is you can have your Prometheus's IP address as the primary server, and you can still use Columbus as the secondary server IP address. So that if something does go wrong with your DNS service while you're configuring it, or even after you've configured it, then you will still be able to have general internet access. So if your DNS server isn't working and you have 2 DNS servers configured, you will still be able to ping Google and browse the internet, but you will not be able to ping your vPrometheus 012, for example, if there's a problem whatsoever with your primary DNS server. Okay, so there are little tricks like that that we can do, and we'll show all that in the lab as well anyway, so don't worry. And that's pretty much it. So I understand it might sound a bit convoluted and everything. It's because you haven't been in the lab yet, so you haven't built the network, played around with the IP addresses and the virtual machines and everything. But hopefully, once we're in the lab, this should be a bit clearer and easier to understand. Okay. Any questions about all this, please? No, we will not be using VirtualBox. We'll be using VMware Workstation Player 16. Yeah. I generally don't like VirtualBox too much. I prefer VMware. And if you come to when you reach the second year, if you do my cloud computing unit, we actually install both of them and we build the network using both. So we build it once using VMware and once using VirtualBox. And I do actually ask the students to do comparison and tell me, which one do you like best and why, and so on. So yes, they are quite similar, but they have a few small differences. So generally, when we go into the labs, definitely in the first lab session next week, I will quickly do a refresh, explain everything that we're going to set up the operating system as well. Okay. However, the next weeks, I cannot re-give this lecture 4 times a day for every week. Okay. This is the reason why we do it online, not in person, because this is recorded. So before you come into the lab, if you want, you should go back on Moodle and look at the recording for each of these lectures. And yes, of course, I will be there, and possibly one of my MSc students will be there as well to help, and will just to guide you through everything. So anything you get stuck on, my job will be to be there and help you through it. Okay, so it's nothing to worry about it. It's quite fun in the lab, actually. It's quite nice. And even if you do break everything, you can't really break the computer, and you can rebuild it very quickly, and I can help you restore it and so on. So, it's nothing to worry about in the lab, really. Anything else? Okay, then, so I'll stop the recording.